Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Ellumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Ellumen's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Ellumen's website at www.ellumen.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Myself and Todd have run this podcast over the couple of months, and we just thought to ourselves it would be really good to really shed some light on some of the work we do in-house and how we came about some of those work, some of those jobs, or some of those opportunities, and share this experience with our audience.
So what I was hoping to cover today was a lot about the work that I've done in the past with Ellumen on using electromagnetics to generate what is known as microwave images. And so that's a imaging area that's not currently being used anywhere in hospitals or clinics. It's kind of an emerging modality. And it's something that Ellumen was interested in pursuing a number of years ago, and I got involved with, and I'm, have numerous patents and publications that have came out of that work.
You have actually done some work in distributed microwave image processing system and method. So what's microwave image processing?
Whenever you are collecting imaging data, you always need to, it doesn't really matter, if it's in the microwave field or some other field, you need to be able to take that data and form an image. So when you collect the data, you get basically signals back, and they don't represent an image. So there's various algorithms depending on the application area that you use in order to take those signals and form them into an image. So that's kind of the gist of what the processing is.
Wow. I'd like, to deep dive into how does, especially with microwave itself, because I'm sure there are several methods of processing these images. Is there any other method that you're familiar with that people typically use outside of the microwave image processing systems?
Yeah, I mean, for microwave image processing systems, even within the microwave field, there's different algorithms that are used. There are like stochastic algorithms where you have some randomness that's introduced, and then there's also deterministic algorithms where they follow more like a traditional approach, like a gradient descent algorithm.
I see.
Some of these algorithms are also used in other areas, like when you're reconstructing a CT image and you have the images represented in Hounsfield units, you could feasibly use one of those approaches. And there's also other approaches that are used in the Hounsfield space. So there's a whole host of algorithms available.
So what was your motivation to use the distributed microwave image processing approach? I know you had said that there are a bunch of other methods within that system, but what was the push, towards microwave?
Right. So we came up with an idea and it evolved into a patent that was issued with Ellumen called Distributed Microwave Imaging Processing System and Method. Now, the concept was that if you have some like centralized computing environment location that you can send your imaging signal data to, and then help use that data to aid you in the image reconstructions. If you can centralize all of that, it can allow you to have a lot of unique insights and abilities that you couldn't have done so if you had, just all the algorithm and processing approaches at a single hospital unit. It also allows for, not having to have expensive hardware that does the processing at individual hospitals or sites.
I see. We talk AI ML here. We discuss about how different methods or applications, things that we discuss could be applied to, or how AI ML could be applied to these applications. And so I was just curious, could you share, what application of AI, or what would be an application of AI ML in this specific space of distributed microwave image processing?
For the distributed microwave imaging system, what we were suggesting was you would have this centralized database that would have both the image reconstructions and also the diagnoses that, like if there was some sort of a disease or something found in the actual image, you'd be able to store that diagnoses as well. So the concept was, if you have some sort of a learning program, like a machine learning program, a neural network that could take in a new image that it's never been seen, but you had this centralized system that trained on the images as input and then the diagnoses as output. If you take in this new image, it could then quickly suggest a diagnosis for you without having to have a radiologist or any additional any person look at the image. So the centralized system really allowed for a quick way to allow doctors and anyone really interested on imaging interpretation.
I see. But with regards to the images, though, right? Is there any like image improvement in terms of pictures or representation that the distributed microwave image processing system offers that would make the quality or the precision when it comes to the AI ML piece more effective?
Yeah, I mean, there's definitely different components to this. So the one component is using the AI and ML piece to, suggest a diagnosis. The other component is to use the AI ML piece to help improve the image reconstruction. And by
I see.
having a centralized location, you could also use the AI ML piece to help improve image reconstructions and future reconstructions. So you could feasibly use it on both the signals that you've collected on the data and then also on the images after they've been reconstructed with the AI and ML to help improve both aspects.
Also, I see a work that you've done in the dielectric encoding of medical images space. Do you mind sharing a little bit about that as well?
Sure. We also were able to get actually two patents with Ellumen called dielectric encoding of medical images. One came before the other, naturally. And the concept is these microwave images that we've been talking about, that's usually the term for the data collection. But when the image actually comes out, it's often referred to as a dielectric image. And these dielectric images are not something that radiologists or clinicians really have any familiarity with reading. So they're going to look a lot different than your normal X-ray, CT, or MRI image. So the whole concept was that if we could figure out a way to convert these dielectric images to another image type, like a CT Hounsfield unit image or an MRI intensity image, then a physician and a radiologist would not need to spend all this time and effort to learn how to interpret those images. So what we did was we came up with a method that allows for a conversion from these dielectric images over to another image type like a Hounsfield unit or an MRI intensity image. And the conversion that we came up with initially was sort of like a nonlinear type conversion algorithm.
I see. How also, can you talk about collecting microwave image data, how that works, and also I know you had brought up the whole idea of reconstruction earlier. I think, could you shed more light on how, deconstructing images work with the dielectric method?
Yeah, so at Ellumen, we actually have a system that we built, and we got a patent out of it called microwave imaging device. And what this system is it's basically a platform that allows you to stick an object in the middle of the platform, and there's an antenna or multiple antennas on the outside of the platform, and they're able to rotate around in a track. And these antennas are connected to some sort of an instrument like an oscilloscope or a signal generator or a vector network analyzer that collects either time or frequency domain data and signals. And so basically, the concept is you send out a signal from one of these antennas, it hits the object and then scatters. And then you wait a little bit, and then it comes back to the antenna or another antenna you have positioned, and it collects it collects the data. Once the data is collected, you rotate the antenna a little bit, like let's say 5 degrees, and then do the process again, where you send out a signal, you wait a little bit for it to hit the object and scatter, then you collect the data. And so by rotating around 360 degrees these antennas around the object, you're able to collect data at numerous locations. And then what you do is you take that scattered data that you collected and use it in conjunction with an image processing algorithm, like I talked about a little bit earlier, to basically allow you to reconstruct this microwave image that's basically represented as what I was talking about, a dielectric image.
With regards to medical imaging, right? What do you see as some of its most important applications? Especially the dielectric encoding piece of it.
Just allow me to expand a little bit more on the dielectric encoding of medical images piece. So,
Yep.
when we initially worked on this patent, we had like this nonlinear algorithm that converted from dielectric images to something like a Hounsfield unit or MRI intensity image. And I see a path forward where we could use AI and machine learning to help improve that algorithm and nonlinear relationship in the data to basically improve how those images would appear to the clinicians once they're converted from dielectric over to this other image type like a Hounsfield or MRI intensity image. And so by using machine learning and AI in that fashion, you could help reduce noise in these images, and then they'd basically be a clearer picture that the doctors would be looking at, and would allow them to get a better feel for what's really going on with the patient.
I see. So, I'm very, very curious, and this is just my curious mind, going up and down, trying to figure out, like, okay, my assumption is that, like, let's say, take, for example, the brain, right? Let's use that as a hypothetical example. Will the Where would the antennas be to collect this type of information? And also, would we see the exact same visual representation as we would see in an X-ray, from the pictures that the dielectric encoding presents to us?
If we're talking about the brain, I didn't do this directly, but there are some other researchers that have done this, where they built basically like a helmet that was kind of repurposed from a bike helmet, and they positioned numerous antennas in the helmet, and then you put the helmet on with these antennas and you collect the data, and then you can generate a microwave image, from that data that was collected
See.
on the helmet. Now, yeah, now the approach that I'm talking about here with the dielectric encoding would then allow you to convert that data that you collect in dielectric image representation over to another image type that physicians are more familiar with, like a CT scan. And so it should appear pretty much identical to a CT scan as if you were collecting it from that modality, even though you're actually using, microwave and electromagnetics instead of that other, type of scan, like an X-ray. The idea is that you're using a different way to collect the image, but at the end of the day, after the conversion happens, it would still look basically the same as if you were taking it from the other data type.
Wow, that's super cool. So I know that here at Illumin, we've written a couple of articles, right? And one of those includes the article on could AI be the radiologist's best friend? I want you to tie some of the conversations that we're having here to that specific article. How do you see this really helping, the radiologist? I know we've had a couple of conversations here around the fact that AI will be really a good addition to, a doctor's toolkit as opposed to helping them take care of it all, completely, or as opposed to being the complete cure for every sickness, or if you understand what I mean. So can you share, like, basically what your thoughts are around AI being the radiologist's best friend?
We've talked about some of these concepts a little bit already in relation to some of my prior work,
Yep.
talking about providing decision support
Yep.
and enhancing image quality. So that's definitely something that we talked about in that "Could AI be the radiologist's best friend" article that could be introduced into the radiologist workflow and the use cases. And one thing that would help radiologists accomplish that we mentioned a bit in the article is helping to reduce the amount of time that they need to spend on reading images, because right now radiologists are spending a lot of time looking at all the images they have. They don't necessarily have all the time to do that. And so by providing them better looking images and giving them a sense of what the diagnosis very likely could be before they even look at the image, it can save them a lot of time and help them basically help more patients in their day.
The patients have a variety of issues, right? But then if you have, a system that has done the digging and searching, created the training, and, you can make inference from them, that would further help the radiologist to be able to, or it would be sort of like a virtual assistant to the radiologist. And I'm very careful about the use of word virtual assistant, but more like someone who provides a tool that provides additional help and helps to, bring to light blind spots for the radiologist. So I do agree with you, on that. I was just curious as we're talking about with these images. I know we've been doing a little bit of conversations around, like, 3D imaging and things like that. How can this be applied in the 3D world, if at all?
Yeah, so you definitely could apply this to the 3D world to help improve, these types of things we're talking about here, to improve the image quality and provide decision support.
Yeah, so I was thinking, like, would the dielectric method be able to do some 3D image processing as well?
And when I think of 3D and the imaging space, it's sort of like stacking a bunch of 2D images together to create a 3D image.
Yeah, yeah.
So, the way that I initially conceptualized some of these concepts we're talking about is in the 2D space. But as the processing power of computers increases, as it has been, and you introduce things like GPUs, you could feasibly work on a 3D representation of the image and these stacks of 2D images like I'm talking about, and allow for a lot better representations that you can visualize and show to doctors so they can more quickly drill down and look at the images.
I see. And so it is possible to, take,
For sure, yes.
so, as we wrap up here, I wanted to touch on a few things around, applications of AI. We spoke about one to the radiologist, using dielectric encoding, like those Ellumen has worked on with regards to patents and microwave image processing as well. But I wanted to touch on some other, recent events, taking place in the world, around AI ML, and we're going to continue to build up on some of these conversations in our upcoming podcast. But what are your thoughts, Todd, around just the recent event around Facebook shutting down their face recognition feature?
I initially was a little surprised by it, but I definitely understand why they did so. It's been a program that has kind of been opt-in for a number of years now, but maybe a large segment wasn't aware that they could opt out, and there definitely has been a lot of backlash over facial recognition as a whole.
Hmm.
I know that from my standpoint, like even with Facebook shutting that down, I still feel like there's going to be other companies that could potentially go out there and scrap Facebook photos and then build their own facial recognition algorithms from those photos. And there's one that I'm familiar with called Clearview AI that actually works with local law enforcement agencies to help build a facial recognition surveillance system. And I guess the whole concept of being able to surveil people based on their Facebook photos probably doesn't sit that well with Facebook users, that their data is being used that way. So I can understand Facebook's decision. What are your thoughts on this issue, Yano?
Yeah, I think that like the social impact of facial recognition methods or facial recognition just in general has been like a very like concerning problem to regular to individuals just in general. I think that like as we begin to get into these new worlds of like the metaverse and like some of these things, I think that there are more problems that this could present. And I'm still really trying to process what Facebook was using the data for at the time. Is that something you're aware of? Well, when they were doing this, were they using it more for to present, ads to specific users, or, I'm very curious about what they were using it for initially.
I think the facial recognition feature was like an auto tag feature. So when you upload a photo to Facebook, you can tag yourself or somebody else. And that's a way that you can, find and look back in the past about images that have you or somebody in there.
Oh,
And
that's
if you don't tag that person, it's sometimes hard to find those images. So I think their initial motivation was on like this auto tagging feature,
right,
but it
right.
may evolved into something, way
Yes.
beyond that. But I'm not really sure on all those details.
Right, right. I think their attention is also probably also changing. They're moving into this whole meta thing.
Hmm.
Though I think that maybe because of their shifting attention, maybe because they're shifting attention to the meta space, perhaps that's the reason why they're also shutting this aspect of the business down. That gives them more time to focus on that piece, but. We'll see how things evolve for them, in the coming years. I wouldn't rule out the fact that they might, bring the future back.
Yeah, it definitely is interesting, and we talk about this in the practical AI for the real world article that you mentioned, but we have a sentence in there that says the Facebook facial recognition algorithms, have a reported success rate of 97.35%
That's
when
awesome.
used with publicly available test data sets. So, I mean, these were really solid algorithms that were really good at predicting who was in the photo.
Wow.
But just because they got rid of this feature, they're still using AI in other areas, and we talk about this a little bit on this article about their Facebook learner flow. So
Mm-hmm.
you have a news feed and a homepage. So they're still using machine learning there to help kind of filter out offensive or fake material and maybe provide a better experience for the homepage.
Right, right. Do they have some of their algorithms open source, especially with the image classification algorithm?
They might. I'm not 100% sure.
Okay, okay, okay. Also, another thing I was going to touch on was the Zillow report. Are you aware of that? The whole Zillow AI debacle with Z estimate and losing money.
Yes, for sure. So, to explain to some of our listeners, if they're not familiar with Zillow, so Zillow is a home buying website. And the one nice feature of Zillow is for years they have this algorithm called a Z estimate that basically gives you a prediction of how much money your home is worth. And Zillow in the last couple of years, I think they started in 2018. They decided that their Z estimate was very good. They were very confident in it, and they thought that it was so good that they could use it to help make money in a new business area for them. So what they started doing is they launched this Zillow offers, and it allowed homeowners who were interested in selling their homes to basically have Zillow take a look at their home and use the Z estimate, and then Zillow would give them an offer and basically buy their home from them. And so Zillow, over the course of several years, purchased, I think it was around 27,000 homes. And the market has really changed recently with the whole pandemic. So they were using these AI algorithms on all this past data, and the AI algorithms just haven't really performed as well based on the historic data as what's actually going on today. So what ended up happening was a lot of their predictions on, how much the home was worth, when they'd be able to basically flip the home for and make money on it, just didn't end up being reality. And in addition to that, they also evolved how they were using the Zillow algorithm. So initially they were using 1,000 different models that were ensembled to predict the house price. And then they switched to a neural network model. And basically by doing so, they created some large data drift problems, and I guess the algorithms just weren't giving the predictions that turned out to be very accurate. So there's definitely a good use of AI, But it seems like, Zillow eventually decided that they took a loss, I think, of $304 million in the third quarter on this, and they decided to get out of this business. So I think there's good use cases for AI, but, maybe this shows that you can't just quickly, get an algorithm together and start, trying to use it for millions or billions of dollars without really drilling down and improving, spending the time to improve the algorithm.
Exactly your point. Exactly your point. I think that like a lot of people want to just slap AI tool on a specific problem and expect like, some type of crazy results, right?
Right.
Whereas I think it's better off when you're looking at, okay, how can I apply, AI to my problem, and how does it actually help me to effectively make, the right decision? And how do we continue to even improve that over time, right? Because there are certain times when new, constraints get, introduced. And so really building your system in such a way that it takes into consideration all those nuances become just extremely, extremely important.
Sure. Another factor that I think affected Zillow negatively, like you said, is, about being able to, update your models that you're using. Is, when the pandemic hit, there was a lot of, increases in the price of certain goods, and it became harder to find,
Yep.
contractors who were available to come out and work on the home. And
Yep.
I just don't think they were regularly updating their AI model to take into account these kind of factors.
Yep. Yep. Exactly. That's my, immediate thought. I'll be very curious to look, into the article even a little more to kind of figure out like what they were doing there. And that's even if they make it public, because I think if they do that, there might be some problems.
So yeah, it'll definitely be interesting to see if the fact that Zillow tried this AI model and were so public about it and had basically launched a whole new business on it, and then they decided to shut it down. I'm curious if you think that might deter from other companies from adopting AI, or do you think it's just kind of a lesson that the other companies have to keep in mind when they're adopting their own AI models?
Yeah, in my opinion, I think it's going to be a lesson. Like it's not far fetched now for companies in general to see like the value that AI and ML kind of brings to the table for their businesses. But, I think that like having, a subject matter expert on the topic that is being investigated, if it's real estate, if it's health, if it's finance, depending on whatever it is, would significantly help in making sure that they're able to improve their methods and techniques and are able to arrive at a decision that would, basically work for that specific business. So that's my humble opinion about that, situation. I think we need to see more businesses, looking into like how to explain explainable AI, right? How to explain what it is that their models are actually doing, and how to also improve on them, so that they don't end up in a situation like Zillow had an experience. The message we actually drive at during our podcast sessions, is how useful and how applicable AI is to, these different applications. So really exciting, and really excited that we got to have this conversation today.
There's definitely a lot of use cases for AI. There's a lot of companies that are, starting to use it more and more in their businesses. So it's definitely exciting to talk about some of these things going on.
Yeah, yeah. Thank you so much, Todd, for showing up. It was really awesome getting to have this conversation with you, and looking forward to the next podcast.
Yeah, thank you, Yano. We'll see everyone again shortly for another edition.
All right, guys. Thank you so much for joining.
This has been the AI Innovation Space, sponsored by Ellumen. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Ellumen website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.